This problem says find the required annual interest rate for $500 to grow to $700 if interest is compounded quarterly for 8 years. So to solve this problem, we can use the compound interest formula, which is right here. A is equal to P times 1 plus R over N to the power of N times T, where A is the ending amount, P is the principal or the initial amount, R is the annual interest rate, N is the number of times that the interest is compounded annually, and T is the time or the years. So for this example, we're going to use this formula and we're going to solve for R, the interest rate. So let's go ahead and fill in all the values that we know. A, that's the ending amount. So we want the ending amount to be $700. So here's what we can write. 700 is equal to P, that's the principal or the initial amount. So the initial amount is 500. So we'll say 500 times 1 plus, we have R, we don't know R, so we'll leave it as R, divided by N. N is the number of times the interest is compounded annually. So we're told it's compounded quarterly, which means it's compounded 4 times per year. So we'll say 4 for N, and then we have to the power of N times T. So 4 times T is time, or the number of years, which we're told it's going to be compounded for 8 years. So 8 will be our T. So here's our equation. We're just trying to solve for R. So the first step we could do is divide both sides by 500. So we'll get rid of this 500 out front. So if we do 700 divided by 500, that's equal to 1.4. And that's equal to 1 plus R over 4 to the power of, we have 4 times 8, which is 32. Okay, so to solve for R, we want to get rid of this pesky 32 in the exponent. So one way to do that is to raise this entire quantity to the power of 1 over 32. Because when we have an exponent raised to another exponent, the way to simplify that is to just multiply the exponents. So when we have 32 times 1 over 32, this whole thing would just become 1. So it would have an exponent of 1. So we can also do that to this left-hand side right here. We'll say let's raise it to the power of 1 over 32. So when you punch this into a calculator, 1.4 to the power of 1 divided by 32, you get about 1.01057. And that will be equal to, over here we said these exponents are just going to cancel out and become a 1. So we have 1 plus R over 4. Now to solve for R, we can subtract a 1 from each side. So we get, I'll write it over here, 1.01057 minus 1 is just 0.01057. And on the right-hand side, these 1's cancel out and we're left with R over 4. The last step to solve for R is to multiply both sides by 4. So when you do 4 times 0.01057, you get about 0.04228. And on this right-hand side, these 4's cancel out and we're left with R. So here's our answer. If we want to write it as a percentage, we can just move the decimal point 2 places to the right. So our final answer is going to be R is equal to 4.228%. So that is the interest rate that is required for this $500 to grow to $700 if it's compounded quarterly for 8 years.